Okay, for the second part of this video, we're going to talk today about calculating the relationship between an energy transition and the actual wavelength that's going to be emitted. So if you will recall from the reading, we read that there's various principal energy levels, and that as an electron goes between these various energy levels, it either emits or absorbs energy. And then that is generally, let's talk about the emission part. When the electron falls from one level to another, it emits energy in the form of a photon of light. And then that photon of light can be quantified as a bundle of energy that we can then translate into a wavelength. And then we can apply the wavelength to our electromagnetic spectrum and figure out whether it's in the visible spectrum. Generally, we say if it's longer than 700, then it's generally in the infrared. And if it's shorter than 400, then it's most likely ultraviolet. So let's look here at a problem that we might get. So say, for example, I told you that an electron was transitioning from energy level 4 to energy level 3. And so we wanted to know how much, not only how much energy that is, but then also translate that to what is the wavelength that's going to be emitted. So what we do is we take our calculations and we say that the change in energy is equal to final, which is the energy at 3, minus initial, which was the energy at level 4. Okay? And delta E is equal to, so the way that we calculate these energies, remember in the book there is a formula that says negative 2.18 times 10 to the negative 18 joules times 1 over whatever the energy level number is. So in this case it's energy level 3, so it's going to be 3 squared. If it was energy level 4, it would be 4 squared, and so forth. So in the formula it says n squared. Okay? So that's the amount of energy right here in energy level 3. Okay, we're going to subtract that, and we're going to take negative 2.18 times 10 to the negative 18 joules, which is a constant, times 1 over energy level 4, so that's 4 squared, okay, and we're going to find out that number. So basically 1 over 9 times this number becomes negative 2.42 times 10 to the negative 19 joules. So that's how much energy approximately energy level 3 has. Okay? And then we're going to subtract that from the energy in energy level 4. So we're going to take negative 2.18 times 10 to the negative 18 times 1 over 16, which is 1/16, which is 4 squared. And that's negative 1.36 times 10 to the negative 19. You should be checking my work with your calculator as well. Make sure that this makes sense. Okay? And then we're going to go to basically taking these numbers and subtracting them. Now this is a negative, so just kind of be aware of that. So delta E is basically equal to this number and then adding this number, and we end up with a negative 1.06 times 10 to the negative 19 joules. Okay. Now remember, this is the change in energy, but because this is how much energy is actually released, we assume the conservation of energy, so we assume that the change in energy, okay, is equal to the actual energy of the photon, except a negative sign because one is absorbed and one is emitted. Okay? So even though this is how much energy is lost, the energy of the photon would be a positive number. So when we're actually calculating the wavelength, we're going to say E of the photon is equal to 1.06 times 10 to the negative 19 joules. Okay? So this is how much energy was lost. This is how much energy the photon has. Same number, different sign. Now we're going to take the formula that says that the wavelength of a wave is equal to hc over E. H being Planck's constant, so that's 6.626 times 10 to the negative 34 joule seconds times the speed of light, 3.00 times, sorry about that, 3.00 times 10 to the 8th meters per second. And we're going to divide that by 1.06 times 10 to the negative 19 joules. Now, if you ever kind of struggle with your formula manipulation, unit cancellation is the way to go. Because if your units don't cancel, then you did not set it up correctly. So here my joules are canceling, my seconds cancel, and I have meters, and that's good for wavelength. So I take these three numbers, plug them and chug them, and I end up with 1 point, and it looks like I have three significant figures, so I'm going to go 1.8 and round up to 8 times 10 to the negative 6 meters. Okay, so that's the wavelength of the photon that is emitted when I transition from energy 4 to 3. Now, we have one last thing to do, and that is we'd like to predict what kind of a wave is this. If it's visible, what color? If it's not visible, is it longer than the visible spectrum and therefore infrared, or smaller than the visible spectrum and therefore ultraviolet or UV? Okay, so I'm going to move this to 18.8 times 10 to the negative 7 meters, because then in my head I know that when I move from meters to nanometers, I get rid of the decimal place and add 2 zeros. So this is, 1 zero. This is going to be 1880 nanometers, which 1,000 is way bigger than 700, and so this is definitely in the infrared range. Okay, and that should help you do the calculations for your fall work in this assignment.